Hello, and today we're going to talk about statistics, tables, and graphs. So one of the first things we need to talk about when we're talking about statistics and graphs is we need to talk about the difference between qualitative versus quantitative data. Quantitative data basically consists of numbers representing counts or measurements, whereas qualitative describes some kind of quality to them, so that could be either their name or color, gender, etc. And so what we're going to do is we're going to try and classify each of the following types of data as either qualitative or quantitative. So the birth months of individuals, because the birth month is a name, this is qualitative. Annual salaries of NFL football players. Salary is a numerical value, so that is quantitative. And the response of customers at a restaurant on a scale from 0 equal terrible to 5 equals fantastic. Even though the responses are rated from 0 to 5, the numbers actually have a qualitative meaning instead of a quantitative meaning. So this would actually make this qualitative. And for the last one, since we're dealing with the amount of rainfall, this will end up being quantitative. For this next problem, we're going to look at frequency tables. And frequency tables is basically just a way of collecting groups of numbers within a certain range. So what we're going to end up doing is we're going to take the pulse rates of females and make a frequency table out of it. And this usually helps if we rearrange this from smallest to largest. So that's what I basically did in the table below. So up at the top I have pulse rates of females. And in the far table on the left, we're going to fill in the frequencies, or how many I count for each category. So doing some counting ahead of time, I found that there are 12 pulse rates that are between 60 and 69 inclusive. There are 14 between 70 and 79. There are 11 between 80 and 89. One that's between 90 and 99. Another one for the next category, 0. And then finally we have a heart rate of 124 beats per minute, so that is the last one we have in the category. So adding all these together, I believe we had 40 pulse rates. So to figure out the other two tables, we would need to find the relative frequencies for each category and then the cumulative frequency for each category. To find the relative frequency, we take the frequency in each category and we divide them all by the total frequency for the whole table. Now, looking at the relative frequency distribution table, what we do is we basically go ahead and look at the frequencies. So I can actually go ahead and start writing that out. And what we're going to do is we're going to take that divided by the total. So if we take 12 divided by 40, that gives us 30%, or 0.3. And it's okay to write relative frequencies either as a fraction, decimal, or a percentage. Of course, MyMathLab will ultimately tell you how it wants the problem. So same thing, 14 divided by 40 equals 35%. And you just continue on through the rest of the table. And adding those up together, we should have 100%. Now, looking at cumulative frequency distribution table, we're basically just looking at how many pulse rates are less than each number. So we have 12 pulse rates that are that are less than 70. We have 12 plus the 14, so there are 26 pulse rates that are less than 80. Adding another 11 to that, we end up having 37 pulse rates that are less than 90. Of course, we can also count all of these pulse rates up here and count that there are in fact 37 of them. Adding one more to that, we have 38 pulse rates less than 100, and then another, so then we have 39 for less than 110. We don't have any more that are between 110 and 120. And then finally, all 40 pulse rates are less than 130. So I will admit that the total doesn't really make sense in this case. Although if they do want a total I guess it'd just be the 40 pulse rates. Now, what we do with the tables is ultimately up to the statistician or the researcher who is gathering the data. So some of the cases that we can do is we can make bar charts, we can make pie graphs, we can make what's called a histogram, and etc. So there's a lot of different graphs we can make. Some are more useful than others. In general, pie charts are not very useful because it's very difficult for people to tell how much bigger one section is compared to the other. I do have a link right here that you can definitely check out. And this has a bunch of really bad charts that range from just flat out mistakes to tricks that people use even today in their histograms or bar charts or other types of graphs. So a histogram is basically just a graph in which the data categories are quantitative. And what's really important about a histogram is the fact that each of the widths are the exact same distance. So this is a histogram for the last example, where we had values that range from 60 to 69, 70 to 79, and so forth. And this kind of gives us a general shape of what uh, the overall data lies in. And what we can do is we can take that and create a line chart that basically connects all these points. So maybe if we took a midpoint, so if we put a point here, point here, point here, 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 and here, I guess we have a point there as well. But if we took all those midpoints and connected the dots, we end up getting a line graph. And of course, I'm not able to draw a very straight line, so I'm sorry about that. And that's all I have for you today. So I hope this was helpful, and please let me know if you have any questions.